Hey everybody. So we're getting into 9.1 today, looking at parallelograms. Okay, this first slide gives you the overall definition of it. So go ahead and copy this whole slide here, and then we'll get into it. Okay, so first things first, what is a parallelogram? Well, here's what it says. It says a parallelogram is a quadrilateral. So first things first, quadrilateral is a polygon with four sides. Okay, so it has four sides with both pairs of opposite sides parallel. All right. So when we're talking about opposite sides, those are sides that are across from one another. So this side PQ and this side SR would be considered parallel to one another. And we can see that on this picture because, yeah, it has those arrows, which, mean they're parallel. And then also these opposite sides would be parallel. Okay. So if both pairs of opposite sides are parallel, we have a parallelogram. There's a few more things. It says the term parallelogram PQRS can be written as this. So this is a shorthand for parallelogram that you might see this little, slanted polygon right there. Okay, so that means parallelogram PQRS. And this says, what we basically already know. In parallelogram PQRS, PQ is parallel to RS. Just remember that's the shorthand for the word parallel. And QR is parallel to PS. Okay, so yeah, we already went over that. Okay, so opposite sides parallel. That's all it means for it to be a parallelogram. But we have a lot of rules that we get when we're dealing with parallelograms, and that's really the focus of this lesson. So let's take a look at the first one. All right, so here are really the first two rules we get when we have parallelograms. Go ahead and copy both of these, get the shapes and everything, and then we'll go over it. All right, so this first one is saying if a quadrilateral is parallelogram, or in other words, if we have opposite sides parallel, then here's what we get. Then the opposite sides are congruent. Okay, so not only are the opposite sides of a parallelogram parallel, they are also congruent to one another. They are the same length. Okay, the next thing is a similar idea though with angles. It's saying if a quadrilateral is a parallelogram, then its opposite angles are congruent. All right, and we can see that here. These opposite angles, remember opposite just means right across from one another. Q and S would be considered congruent angles. They'd be the same measure. And same thing with angle R and angle P. Those would also be congruent to one another. Okay, so congruent sides, congruent opposite sides, and congruent opposite angles. Those are our first two rules. Okay, so with that in mind, let's try out an example asking us to find a couple of missing variables. Copy this and we'll do this one together. Okay, so find x, find y. So let's start with x. I can see that x is part of this side length right here. All right, and first of all, we have a parallelogram, right? Here's what we know about these opposite sides. They are congruent. Okay, so just like so many equations we make in this class, we can set these opposite sides equal to one another and solve. Okay, so I know that x plus 4 is equal to this opposite side 12. Okay, really simple math here, right? We subtract 4 from both sides. Okay, it looks like x is going to equal 8. Yep, so easy enough. When it comes to finding y, maybe even more easy. We can see that y is one of our angles, all right? And we know that when we have a parallelogram, opposite angles are congruent, okay? If this angle is 65, this angle is 65. And so there's really no math to be done. Let's just go ahead and show it. Y equals 65 degrees. Okay, so yeah, first couple rules, really simple idea. Just remember, if they give you strange values, you'll actually want to, set them equal and solve for the variable, though sometimes you can just do some of this in your head. All right, so from here, we have another new rule. Go ahead and get this one, and we'll go over it. Okay, so this is saying if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Okay, so a couple things. Let me remind you, the word consecutive. You guys remember consecutive means things that are side by side, or you can think of it as touching one another. All right, so and we're talking about angles here. So consecutive angles, here's an example. This angle here and this angle here would be considered consecutive angles. They're side by side. They're not opposite one another. They're next to one another. They're consecutive. Okay, and here's what it says. Consecutive angles are supplementary. All right, that's a word we've seen a lot. And if you don't remember what it means, they basically tell you down here, it means that these two angles, when added together, equals 180 degrees. Okay, but if you wanted to add a little note into your notes, you can say add to 180, though I'm sure most people have memorized what the word supplementary means. Okay, so yeah, consecutive angles are supplementary. Here's the big thing I want to point out. These angles right here, yeah, they add to 180. They're not our only consecutive angles. Okay, this angle Q and this angle R would also be consecutive. Those would add to 180. Okay, this angle R and this angle S would be consecutive. They add to 180. Angle S and angle P would be consecutive. They add to 180. Okay, so all of these side-by-side angles add to 180. All right, cool. So with that, let's go ahead and find all the missing angles on this problem. Go ahead and copy this and we will do together. Okay, so this problem is giving us just one of our angles of our parallelogram, and they want us to find all of the missing angles. Okay, we could really start anywhere that we'd like. Here's where I would start. I know that when it comes to parallelograms, opposite angles are congruent. That's the easiest one to get. If this one's 95, I know this angle opposite it is also 95. Okay, so let's go ahead and write out angle P, 95 degrees. Okay, N and L are opposite. We don't know either one though, so we can't really use that rule, but now we can use our new one we just learned. We know that consecutive angles add to 180, right? So we can pick any of these, but I'm gonna focus on M and N. These are consecutive angles. They add to 180. So, you might be able to do this in your head, but when in doubt, we can just take 180, subtract this angle, 95, and it'll give us the other angle, looks like 85. Okay, so there's the measure of angle N. It is 85 degrees. Okay, so let's go ahead and get that. Angle N, 85 degrees. Okay, and from here to get angle L, we can use either method. Opposite angles are congruent or consecutive angles add to 180. Either way, we know this thing is 85 degrees. Okay, so yeah, pretty simple rules. Try not to get them mixed up, but they're pretty simple. All right, let's keep moving. Okay, so from here it says if a quadrilateral is a parallelogram. By the way, before I get into it, go ahead and copy this, then we'll go over it. Okay, so this is the fourth rule here, and it says if a quadrilateral is a parallelogram, then its diagonals bisect each other. Okay, couple things. First things first, diagonals. Okay, these are segments that go from one angle to the other. I guess we should use the word vertex. Okay, it goes from one vertex to another. So this green segment right here, QS, would be considered a diagonal of this parallelogram. Okay, this other segment going from P to R would also be considered a diagonal. Okay, so diagonals go, you can think of it as just going kind of across the polygon here. Okay, and here's the rule. These diagonals are bisecting one another. If you guys remember, when something is bisected, it is cut into two congruent halves. So if we were to focus on this green diagonal, QS, we can see that, yes, it's being bisected. It's being cut into two congruent halves. Okay, so this little segment right here would be congruent to this little segment there. Okay, and the same thing's happening with this diagonal PR. It's also being bisected, cut into two congruent halves, which, by the way, is what these little things say down here. Okay, so diagonals are bisected. All right, so with all of that, I'm gonna have you guys try out some of these problems on your own. Okay, go ahead and copy these and try out these four problems. Do them in the order, numbers 1, 2, 3, and 4 in that order. I think it'll make it a little easier, maybe. We'll see about that. But yeah, so go ahead, try these out, and see if you can find all these missing measures. Okay, so first things first, we have segment NM that they're asking us to find. Let's highlight it. So NM, it looks like we're looking for this segment right here. All right, well, here's maybe the first thing we should look at, the directions. They're saying find the indicated measure of parallelogram JKLM. All right, so I guess maybe one thing to add to this, just to really show that it's a parallelogram, let's put our little arrows to show, okay, these opposite sides are parallel, and these opposite sides are parallel. Okay, something you probably assumed because we're only dealing with parallelograms. But if you were to get this problem randomly, you'd first need to realize, oh, is it a parallelogram? Okay, then these rules apply. Okay, now that we know that, here's something I know. This segment NM is part of this entire diagonal. Okay, and here's what I know about the diagonals of a parallelogram. They are being bisected. Okay, so I know that this one's being cut into two congruent halves. So if you want to show yourself this segment is congruent to this one, or in other words, if this is 2 feet, this is 2 feet. Okay, and there's number one. Okay, this kind of leads us into the next problem. Km is the next thing we're asked to find, and that is, let's see, I'll highlight it, I guess in blue. Km is this entire diagonal. Okay, well, it's a pretty simple idea, right? If this part of it's 2 and this part of it's 2, the whole thing is 4 feet. Yep. So yeah, nothing too shabby there. Let's take a look at these angles here. The first one's asking us for the measure of angle JML. First things first, let's figure out where is angle JML. Okay, so if you guys remember, when we name angles, we start at the side length, make our way around the angle to the other side. So if we're doing JML, notice we're looking for this entire angle right here. Okay, this one is a little tricky. So let's kind of break this down for a second. If I'm looking for this green angle, which by the way, let me clean this up a little bit. Okay, so yeah, we're looking for this green angle, right? Okay, here's what we know. Part of the angle is 30. Part of it is 30. Here's maybe something you might be tempted to do. You might be tempted to think, oh, if this is 30, this other half of it is 30, and the whole thing is 60. Okay, we can't assume that because we do not know that this angle is being bisected. We don't know if it is being bisected. That's not one of our rules. Okay, it's not necessarily being cut into two congruent halves. Okay, well, what else do we know about angles? Well, we know that this angle right here, 110, and the angle we're looking for are consecutive angles. Okay, we know when it comes to parallelograms, consecutive angles are supplementary. They add to 180. All right. Well, with that in mind, we can probably just do this in our head. If this is 110 and this, angle adds to it to get 180, it has to be 70 degrees, right? So this is getting kind of messy. I'm going to put it on the outside, maybe put a little arrow. Okay. But yeah, there, our angle is 70 degrees, the big one. Okay. Now this leads us to question number 4. They're asking us for the measure of angle KML. Okay. Let's first figure out where that's at. Right, so KML, I'm starting at K, going around M to L. That is this part of my angle that we're looking for. So this is what we're looking for on number 4. Okay, well, here's what we know. The entire angle is 70. This part of it is 30. 30 plus what gives us 70? 40, right? Okay, so there it is. And again, this is getting super convoluted, so I don't even know where to write this. Maybe we don't even need to write it on this paper. I'm going to fit in right here, 40 degrees. Okay, so these are seemingly very simple. I mean, they are very simple. It's just really focusing on what rules is being used on this lesson. Okay, so last thing, I want you guys to try one more of these problems on your own. This one is asking us to find the directions say find FG. Let's go ahead and do that. Okay, so on this problem, you're finding FG. Just to kind of get you started, this is FG. This is what you're looking for. Okay, there might be more information on this problem than you need to be able to find FG. Okay, so go ahead, try to make your equation and see if you can solve for your variable and then plug it back in to get what FG is. Okay, try it out. Okay, so this, there's a lot going on here. First things first, if we're finding FG, we need to figure out what Z is, right? After that, we can plug it back in. We can figure out the actual length of this. And I can see over here, this opposite side length also has a Z in it. Okay, and here's what we know about these opposite sides. Since this thing is a parallelogram, they're congruent, they're equal. Okay, so that is the equation here. I'm going to be able to say that this side length, 3Z plus 8, is equal to this side length, 5Z minus 16. All right, just something to point out. These values here and here, that's extra information. If they asked us to find W or maybe one of these segments, we would have used that information, but we had to ignore it and only focus on what mattered to us, right? Okay, on this problem, solving for z, we can bring our variables to either side. Remember, I'm going to subtract the 3z over to the right here. Okay, so that's leaving me with 8 on the left. Looks like a 2z on the right, minus 16. Okay, from here, we can solve for z, right? First thing is getting rid of that 16 by doing the opposite operation. So we're going to add 16 to both sides. It looks like we're going to get 24 equals 2z. Last thing, dividing both sides by 2 to solve for z. I'm going to get a 12 equals z. I'm going to flip it around and write it as z equals 12. Okay, be careful. You'd be tempted to stop here, right? But this problem didn't say solve for z. It said find the measure of fg. Okay, so we're close. This is definitely going to help us get our answer. So sometimes I like to underline it, but it's not my answer. I got to go one more step and plug it into this side line. Okay, so off to the side here, let's go one more step and let's go ahead and say, okay, fg equals 3z plus 8. And now we can plug in what we got for z. Okay, so fg equals 3 times 12 plus 8. All right, and let's see, I'll grab my calculator because I'm lazy. So 3 times 12 gives me 36 plus 8 looks like it's 44. Okay, and I always look like to see if we have units. When we're talking about like the lengths of sides, is it inches or feet or whatever? I don't see any units here, so we'll just leave it. Or maybe we can put the generic just units next to it. All right, guys, so yeah, that's using parallelograms. You're going to see there's a lot to do with the various types of parallelograms. We're going to get into more and more specific types. I actually really like this chapter. It's kind of fun, though you might not think so. All right, guys, I'll see you in class. Bye.